Welcome back to our deep dive into databases.
Mhm.
Last time we talked about like the evolution of databases, from those early file systems
Yeah.
to relational databases, data warehousing,
Mhm.
even NoSQL. Yeah, we
Go
covered
for
a
it.
lot of ground.
Yeah.
But, knowing the history is fascinating,
hmm
but I think I'm also curious about like the practical side of things.
Okay.
How are databases actually used?
Yeah. Yeah. The textbook actually talks about some different types of database applications.
Okay, cool.
So let's dive into those.
Yeah, let's do it. Give me some real world examples.
Okay. So one example is a sales contact manager.
Oh,
It might not sound that glamorous,
right.
but for a salesperson, it's a lifesaver.
Okay, how so?
It's a classic example of a database application that helps you organize all your customer information, track your interactions, manage your sales leads. Instead of shuffling through stacks of business cards,
Right, right.
you have everything right there at your fingertips.
That's a great point. It's easy to forget, I think, how much databases have streamlined things.
Yeah.
What about other industries? I imagine like healthcare
Yeah.
relies heavily on databases.
Huge, huge. I
Yeah.
mean, think about patient appointment systems, right?
Okay.
Medical offices, dental offices,
Right.
managing patient records, scheduling appointments, handling billing,
It's all in the database.
powered by databases. Yeah.
Okay, so those are kind of like everyday examples.
Yeah.
What about larger organizations?
Okay. Yeah.
How are they using databases to tackle maybe like more complex challenges?
Well, that's where you start to get into things like CRM systems.
Okay. CRM, now remind me what that stands for again?
A customer relationship management.
Okay, right.
So these systems, they help businesses manage all their interactions with their customers,
Mhm.
track sales and marketing campaigns, provide personalized customer service. It's like having this 360-degree view of each customer, all their information.
CRM sounds pretty intense.
Yeah, it can be.
But what about like those giant companies, the ones that have, operations spanning multiple departments, even multiple countries?
Yeah.
How do they manage all their data?
That's where you get into ERP systems,
Okay, ERP.
which stands for Enterprise Resource Planning.
Okay.
And these are massive integrated systems that manage an organization's like core business processes.
Uh-huh.
So everything from finance and accounting to HR to supply chain management, it's like the central nervous system of a large company.
Wow.
Keeps everything running smoothly.
So ERP, that's really for those like really large, complex organizations.
Yeah, pretty much, yeah.
We can't forget about the online world though, right?
Yeah.
E-commerce
100%.
relies heavily on databases too, I'm guessing.
Huge, yeah. I mean, think about online retailers like Amazon.
Right.
And they have to manage massive product catalogs, process orders, track inventory, personalize the shopping experience for millions of customers. Databases are the engine behind all of that.
It's kind of mind-boggling how much data is flowing through those systems like every second.
It is. It's incredible.
It's not just about processing transactions though, is it?
No, not at all. It's about understanding customer behavior
Right.
and using that data to make recommendations.
Yeah, like those targeted ads and stuff.
Exactly. They analyze what you're browsing, what you're buying, what you're leaving in your cart, and then all that data gets fed into these algorithms that personalize your shopping experience.
It's like having a personal shopper but powered by data.
That's a good way to put it.
So e-commerce, really, really data driven.
Yeah, totally.
But it's not just e-commerce, right? I mean, data analytics is becoming crucial across so many industries.
Absolutely, yeah. We're seeing the rise of these digital dashboards, data mining tools.
Yeah.
And these tools, they allow businesses to extract like really valuable insights from all this data they're collecting.
Okay.
Identify trends, make more informed decisions.
So it's not just about storing data. It's about like analyzing it, finding patterns, using those insights to like make better decisions.
That's the goal, yeah.
Okay, so we've talked about some pretty amazing applications.
Yeah.
But I want to make sure we're not like losing sight of the kind of the foundational concepts.
Okay.
The textbook, it dives into the structure of databases. And one term that comes up is metadata.
Right.
What exactly is that?
Metadata is essentially data about data.
Okay.
It's like a blueprint for your database.
Okay.
It describes the structure of the data, including things like table names, column names, data types, relationships between the tables. It's like a map that helps you understand how everything is organized.
So if the data is the content,
yeah,
metadata is like the context.
Exactly. It tells you what the data actually means and how it's all connected.
And without metadata, I'm guessing a database would just be like a jumble of...
Yeah, it would be useless.
Yeah, a mess.
Metadata is crucial for managing and using the data effectively.
Right.
You know, it ensures data consistency. It enables you to retrieve data efficiently. It makes it possible to share data across different systems. It's really important.
The textbook gives an example of a student database. Can you maybe walk us through that and explain how metadata plays a role?
Yeah, so let's say you have a database with tables for students, classes, and grades.
Right.
The metadata would tell us things like, you know, the student table contains columns for student number, last name, first name, email address. The class table has class number, term, section, and the grade table stores student number, class number, and grade. So it's basically telling you what each of those columns actually represents.
Gotcha. So it's making sure that, like, last name in the student table actually refers to a last name.
Exactly.
And grade in the grade table refers to, you know, the grade they got.
Right.
It's adding that layer of, like, meaning and structure.
Exactly. Without metadata, you wouldn't know what any of those columns actually represent.
Right.
Or how the tables are related. It's the glue that holds it all together.
Okay, so metadata, kind of the unsung hero.
Yes, for sure.
Of the database world. Let's shift gears a little bit and talk about database management systems.
Okay.
Or DBMS. What role do they play in this whole, you know, database ecosystem?
Well, a DBMS is basically the software that allows us to interact with the database.
Okay.
It provides the tools to create, manage, and access the data that's stored in the database.
So it's kind of like the interface between us.
Yeah, that's a good way to think about it.
And the database.
Yeah, it's like the operating system of the database world.
Okay. So what are, like, the key functions of a DBMS? What does it actually do?
So a DBMS handles things like creating and defining the structure of the database, managing data storage and retrieval, ensuring data security and integrity, and even handling backups and recovery. It does a lot.
It's like a pretty demanding job.
It is. But in addition to those core functions, modern DBMS also provide tools for data analysis and reporting.
Okay.
So they allow us to extract meaningful insights from the data as well.
Right.
They're constantly evolving.
Yeah, they have to.
Yeah, to keep up with all the demands of the data world.
The textbook mentions structured query language, or SQL. How does that fit into all of this?
Okay, so SQL is basically the standard language for communicating with relational databases.
Okay.
It's what we use to actually, like, retrieve data, modify data, define the database structures.
So if the DBMS is the operating system, SQL is, like, the language.
It's the language we use to talk to it.
Gotcha. And it's a language that's used across a lot of different database systems.
Right, yeah. It's a very valuable skill
Gotcha.
to have if you're working with data.
Speaking of different systems, the textbook highlights Microsoft Access as an example of a personal database system. What makes that different from these, like, large-scale systems that we've been discussing?
So Microsoft Access is designed for, you know, individual users and small work groups. It's much more user-friendly, and it tries to kind of hide some of the technical complexities of database management.
Gotcha.
Think of it as a simplified version of a full-fledged DBMS.
So it's kind of like a gateway drug to the world of databases?
Yeah, you could say that.
Yeah.
It's a great way to get comfortable with, like, the basic concepts without getting overwhelmed by, you know, all the technical stuff.
We've talked about relational databases, NoSQL databases, and now personal database systems like Microsoft Access.
Yeah.
It seems like there's a whole universe of, like, database technologies out there.
There is.
How do you choose the right one for a particular, you know, application or project?
That's the million-dollar question. You know, the choice really depends on the specific needs of the application. You know, things like the volume of data, the complexity of the data, performance requirements, security considerations.
It's a lot to consider.
It is.
There's no one size fits all.
Exactly. It's like having a toolbox.
Yeah.
Full of different tools, each one designed for a specific purpose.
So you need to, like, carefully consider what you need.
Right.
And then choose the database technology that fits those needs best.
Yeah, that's the key.
This has been a whirlwind tour
It has.
of the database landscape. I mean, we've explored different types of databases. We've delved into their structure. We've even talked about like the tools we use to interact with them.
Yeah.
But I have a feeling we're just scratching the surface.
Oh, definitely. The world of databases is constantly evolving.
Okay, so we better keep exploring.
Oh,
We'll continue our deep dive into databases next time,
sounds good.
where we'll delve into some of the bigger issues and trends that are shaping the future of data.
I'm looking forward to it.
Until then, keep those database neurons firing.
Yeah, stay curious.